Okay, so this is problem 6.3.27. They ask us to verify the identity, and they give us the cosine of 2x over 1 minus sine 2x equals cosine x plus sine x over cosine x minus sine x. When you're verifying the identity, what you're trying to do is you're trying to take one or the other of the sides of the equation to manipulate it and make it look like the other side. And usually we just stick with working with one side of the equation and try to manipulate it into the other side. Very rarely will you actually work with both sides. If you try to work with both sides frequently, you'll find it becomes more complicated. So when I look at this problem, the way I think of starting this, and I worked this problem before doing this video, because verify the identity, sometimes you work things wrong, and that's just the way it goes. I shouldn't say wrong. Sometimes you can get down a path that is going to be more difficult. And so there's a number of tricks with verifying the identity, and you just try some. And if it's not working, it's not going smoothly, then you try something else. Okay, but so some of the tricks, when I look at something like this, one of the tricks that I think of is I know that there's some formulas to convert cosine 2x into this and the sine of 2x into things that don't have double angles right here. And so initially I thought of using, those formulas. If you go through and you look at some of those formulas, for instance, the cosine of 2x is multiple things. We can think of it as the cosine squared x minus the sine squared x. This is also equivalent to 2 cosine squared x minus 1, and also equivalent to 1 minus 2 sine squared x. Okay. So what you want to do is you want to look at all of these, and I looked at these and I thought, if I convert this into one of these, is it going to get me close to this? This is where I'm trying to go. And I didn't really see it allowing me to go there very easily. It probably could have. But this is the one that actually jumped out at me because I look at that and I see the difference of squares. And I notice up here that if we actually multiplied by something, we would get down to the difference of squares. And so instead of going this route and working with the left-hand side, I decided let me just go ahead and work with the right-hand side. So one of the tricks is to convert, like I was saying right here, and then try to simplify. Another one of the tricks that can be used when you're verifying the identity is you can actually multiply by the equivalent of 1 of some form, that will manipulate it into a form that you want. Frequently, you're going to be multiplying by the conjugate of the denominator, but sometimes you multiply by the conjugate of the numerator. And in this particular problem, I just saw that instead of, and it was because of this cosine squared x minus sine squared x that I saw this. I saw that if I actually work with the right-hand side here, and if I take that right-hand side and I multiply by the cosine x minus the sine x in the top and the bottom. Now remember, you can't change these, right? You can manipulate the form, but since you're working with one side of an equation, you're working with an expression. So you can't, do anything except multiply by the equivalent of 1 or try and change the form or those types of things, okay? So this is multiplying by the equivalent of 1. And the reason that I decided to do this is I noticed, well, in the numerator now I see the difference of squares. And so when I multiply that out, I'm actually going to get cosine squared x minus sine squared x, which is going to get me to what I want in the numerator. Okay, so I'll just multiply it all out for you. We're going to see here if we FOIL. Excuse me. In the numerator, we get cosine squared x. The outside is a negative cosine x sine x. The inside is a positive cosine x sine x. And the last there is a negative sine squared x. I'm a little cramped there. Okay. In the bottom, if we FOIL that, we're going to get cosine squared x. The outside is going to be a minus sine x cosine x. The inside is a minus sine x cosine x, and the last is a positive sine squared x. Okay, so what I'm noticing in the numerator, first off, is my minus and my plus right here. These are going to add to be 0 because those are like terms, and the coefficients are opposite in sign and the same. So in the numerator, we're actually left with In the numerator, we're actually left with a cosine squared x minus sine squared x. I'm going to write a little bigger so you can see it. Okay, and in the denominator, if we collect like terms, notice we have just the cosine squared x, and then we have a minus sine x cosine x, and another minus sine x cosine x. So that's actually a minus 2 sine x cosine x. Okay, and then we also have a plus sine squared x. Okay, so right away I see then in the numerator that cosine squared x minus sine squared x is actually the same thing as the cosine 2x. So, and that's where I'm trying to go, right? I'm trying to get to show that this side is equivalent to that side. Okay, and then in the denominator I was hoping to see 1 minus the sine of 2x. So let's see if we have that. Because sometimes you might already have it, but sometimes you might have to do some more manipulating to get there. Okay, and what I see right here is I have a cosine squared x plus a sine squared x. And if I just think about those together, that would actually be the equivalent of 1. And that's another one of our identities. The sine squared plus cosine squared is equal to 1. So for those two, I'm going to substitute in a 1. And then this right here, minus 2 sine x cosine x, is actually the equivalent of a sine of 2x. And so in for that one, we can substitute sine 2x, and that gives us what we had on the left-hand side of our original identity. Okay. So what I want to make really clear is when you're verifying the identity, there are multiple ways to verify the identity. I could have started with this side like I attempted to initially, and it would have been fine. I mean, if I had followed that through, there would have been some factoring that I would have needed to do, but it would have eventually, I could have gotten to this place. Okay. So, you know, there's not just one way to verify the identity. It's why it's really important to show your work when you're doing this. And on a test, I'm going to definitely expect that y'all are showing your work on this because I have to see what you're thinking, how you're making your step-by-step conclusions, because there's multiple ways to do it. Another one of the tricks that I didn't mention because it didn't apply in this problem is to change things into sine and cosine. So in this problem, we were already dealing with sine and cosine, and so that was easy. I just, you know, kept it in sine and cosine. Frequently, if you have something like a tangent or a cotangent or a secant in the problem, you want to actually take those and convert them into sines and cosines and work with them in that format. And it's just much easier that we have so many more identities for sine and cosine. That it makes, generally, it's just a lot easier to verify an identity when you're in sine and cosine. Okay, so 3 major tricks that you can use when you're verifying the identity, just to kind of sum this up. Use some formulas to convert things. You can multiply the top and the bottom by the equivalent of 1, and then you want to change things into sine and cosine. And one of those 3 tricks will generally work when you're verifying the identity.